Have you ever looked up at the night sky and felt its eternity? Stars shining for millions of years, galaxies spinning in a majestic dance that seems like it will never end. Our world feels stable, almost permanent on a human timescale. But this is just an illusion. On a cosmic scale, nothing is forever. Just as the universe had a beginning in a colossal flash known as the Big Bang, it is inevitably moving towards its end. The question isn't if it will end, the question is how. Science today offers several scenarios. These aren't just theories. They are grand predictions based on the laws of physics, playing out over trillions of years into the future, and each one is staggering to comprehend. The most likely and perhaps the loneliest end for our universe is known as heat death, or the Big Chill. To understand it, imagine a hot cup of coffee left in a room. At first it's hot, full of energy, but over time it releases its heat into the environment until its temperature matches that of the room. The energy hasn't disappeared, but it has dissipated, becoming unusable. It can no longer do any work. This phenomenon is called entropy, the relentless march of the universe from order to disorder. Right now, the universe is expanding, and this expansion is accelerating, driven by a mysterious force we call dark energy. So, what happens next? In trillions of years, stars like giant campfires will exhaust their fuel and go out, one by one. First the giants, then the smaller suns like ours. The sky will become black, devoid of light. Later, galaxies will fly so far apart that it will be impossible to see one from another. The universe will become an empty and isolated place. At the very end, only black holes will remain. But even they are not eternal. Thanks to a process predicted by Stephen Hawking, they will slowly, incredibly slowly, evaporate over trillions upon trillions of years, returning their energy to the void. The result? A cold, dark, dead universe. Absolute zero. A silence that will last for eternity. An end where nothing ever happens again. But what if the opposite happens? What if the force expanding the universe one day weakens? Or what if gravity, the unseen conductor of the cosmos, turns out to be stronger than we think? Imagine throwing a ball into the air. It flies up, slows down, hangs for a moment, and then falls back down. The Big Crunch scenario is the cosmic equivalent of this process. The beginning of the end, the expansion of the universe stops. Gravity takes over and starts pulling everything back together. The blue shift. Instead of the light from distant galaxies turning red, it will begin to turn blue as they race towards us. The sky will become blindingly bright. The collision. Galaxies that spent billions of years moving apart will begin to merge. Stars will collide. The universe will grow smaller, hotter, and denser. The finale. Everything, space, time, matter, will be squeezed into a single infinitely small, infinitely hot point. A singularity. In essence, a Big Bang in reverse. Some scientists take this a step further, proposing the idea of a big bounce. Perhaps this singularity isn't an end, but a new beginning. Perhaps our universe is just one link in an infinite chain of births, deaths, and rebirths. And then there is a third, most dramatic scenario. It involves our old acquaintance, dark energy. We've been assuming it's constant or that it weakens. But what if it gets stronger? This hypothetical, ever-increasing force is called phantom dark energy. If it exists, our end will be swift and violent. This is the big rib. Billions of years before the end. The force of expansion will become so powerful it will tear apart clusters of galaxies. Millions of years before the end, it will overcome the gravity holding galaxies together. Our Milky Way will disintegrate. A few months before the end, the solar system won't hold. The Earth will be ripped away from the Sun. Minutes before the end, the Earth itself will be torn apart. In the final moment, the force will become stronger than the bonds holding atoms together. The very fabric of space-time will be ripped apart forever. Which of these scenarios will come to pass? The answer depends on the nature of dark energy, one of the greatest mysteries in modern physics. We know it exists, we see its effects, but we don't know what it is. Perhaps our universe is just one of many in a vast multiverse, born from eternal inflation, where the concept of a single end doesn't even apply. The big chill, the big crunch, or the big rip. These scenarios sound like science fiction, but they are the logical extensions of the laws that govern our world. They remind us of the colossal scales of time and space, and of our tiny but unique place in this grand picture. We live in that brief moment in time when the universe is full of stars, light, and possibility. And while we may never know its ultimate fate, the very fact that we can ask these questions, look deep into the cosmos, and try to understand it all is perhaps the greatest wonder of all.